Hi everyone. So in this video I am going to explain about storage and transition times of the diode. In the previous video we have seen forward recovery time and reverse recovery time, and how the diode is acting as a switch, what are the materials involved, and how the electrons and holes are moving across the junction. That all we have covered in the previous video. Now this video is explaining about the diode storage time. That means when a diode is said to be operated in the forward biased condition, if a sudden voltage is applied in the negative potential, that means suddenly if we inverse the polarities, then how much time the previous voltage stored across the junction or diode, that time is nothing but storage time. Okay, after that again how much time it takes to get back into the reverse biased condition, that is called the transition time. So transition time is time taking by the diode to convert from previous stage to present state, we can say, for our simple understanding. And storage time is nothing but after changing the polarities, how much time that the diode contains the previous voltage. Okay, now see here, consider a diode and a resistor like this. See, this is not a clipping circuit, just for the explanation of the diode characteristics I am taking this circuit. A resistor is a load resistor RL, and it is the voltage V across the diode, and I is the current flowing through the diode, and Vi is the input voltage applied to the diode, positive and negative. Okay, now the input voltage applied across the diode is this is the input voltage. See here, input voltage I am taking from 0 to T1 up to this time instant, we are taking a maximum forward voltage as Vf, and after T1 I am taking a reverse biased voltage as minus Vr, reverse biased voltage as minus Vr, which is a negative potential compared to the previous value. When this type of voltage is applied to this particular circuit, what are the different characteristics that we can come across, we will see. See, first, initially during 0 to T1, from 0 less than T less than T1, what is the status of the diode? You can simply say it is in on state, because we are having highest potential on the P type, and across this cathode there is no potential, low voltage 0, because the other end is at the ground. Then the diode is said to be non-state. When diode is in non-state, what is the current? Some maximum current IF, positive current, is flowing through the junction. We can say this is the current flowing through the junction, and that current we are taking it as electron current minus the equilibrium current Pn0 at the junction. Okay, and this current is maximum current due to electrons up to here. Okay, now if the same current is shown by the current value like IF, then this is the indication, and here it is the current is also flowing like this. All these equations should be drawn one after another so that you can understand the relation among them. See, up to here this is the situation, up to T1 this is the situation, no problem, because the current is flowing, maximum current is flowing through the diode. Now suddenly at T is equal to T1, what happens? We are changing the input voltage, it is equal to now minus Vr. What about the diode now? Diode should be in off state. Diode is in off state. See, it is forward bias voltage, and the last one is the diode voltage. This is diode voltage. Diode voltage. What is the diode voltage? Diode voltage is indicated as V here in the diagram V. Now this diode voltage is a small value like this. Okay. Now what happens after t is equal to t1? T equal to t1, what happens? There is a sudden change in the input voltage from positive Vf to minus Vr. Then the current slowly, the electrons are slowly are going away from the junction, so that the current starts decreasing. So the majority charge carriers, now it will be holes. So that's why the current slowly, the charge carriers slowly decreases across the junction. Hope you understand. The charge carriers I am decreasing now. Now what about the current? Current changes suddenly to the negative polarity. Current changes suddenly to the negative polarity because polarity is exchanged now. It is now minus IR, and it maintains up to some time this negative current, because the voltage across the diode particularly maintains the minority charge storage. It will not immediately lose that charge. It slowly release that minority charge carriers up to certain time period. After that, again, see what happens. Minority charge carriers leaves the junction, and only majority charge carriers leaves the junction, and only minority charge carriers are there. So the current due to minority charge carriers is a negative current, which is very small current. That's why again current goes to stabilize up to that value. This current is known as I naught, which is nothing but reverse biased current, which is a minority charge carrier current. This current I naught is due to minority charge carrier current. Okay, this current is flowing in the reverse direction of the diode, reverse biased condition of the diode. Okay, and that now if you see the diode voltage up to certain point, up to this point, we can say this instant as T2. Take this instant where the majority charge carriers sustains, take it as T2. This is T2 instant. Now from T2, this diode voltage slowly goes negatively, and up to here it goes. This is what? Transition time. This particular period is known as transition time, TT. Okay, and this particular period where the majority charge, the current due to majority charge carriers, it holds for some duration. That voltage is held by the diode for some duration, is known as storage time, TS. This is TT, transition time. And this one, what about this one? This one is forward biased condition. See, in this particular period we can say this is forward biased condition. Reverse biased condition exactly starts from this point, but it takes some time to stabilize. Okay, so diode takes some time to change from forward bias condition to reverse bias condition. This is first point. So diode takes some time to change from forward bias to reverse bias. Okay, so the current I, the initial current, so when resistance RL is assumed to be large, so that the drop across the resistance RL is large compared to the drop across the diode. Okay, the initial value of current is I is equal to Vf by RL. This is when the diode is said to be in forward biased condition. That current is taken as If. That is what I have marked in the waveform. So what happens? At t is equal to T1, input waveform Vin becomes minus Vr. This is yet during Vin is equal to Vf. Okay, so the current reverses. The current I is equal to minus Vr by RL. Same, because the input voltage Vf becomes now minus Vr, so it is minus Vr by RL. Now it is minus R, IR, minus IR. I have shown in the waveform there. Okay, so at T is equal to T2, the injected minority carrier density at the junction drops to 0. This one. At T equal to T2, the injected minority charge carrier drops to 0. Okay. Then the diode voltage falls slightly by after T is equal to T2, the minority charge carriers density reaches its equilibrium state. Equilibrium state is nothing but conventional state. So if the diode ohmic resistance is said to be something like Rd, then at the time T1 the diode voltage falls slightly by if Rs is the Rs or something Rd is the diode resistance then the diode voltage falls slightly by If plus IR by Rd. If plus IR by D. Okay, so after T equal to T2, what happens again? Minority charge carriers completely goes to 0 and only reverse saturation current flows. That I0 is flowing across the junction. Now, the interval from T1 to T2 for the minority charge to become 0 is called, what is that? Storage time. Is called storage time, TS. Okay, the time taken by the diode to make the minority charge to become 0. This particular interval from T1 to T2 is nothing but storage time. And what is the other one? Transition time. The time which elapses between T2 and the time when the diode has nominally recovered. Is called, what is that? Transition time. TT. The name clearly tells that it is the time for the diode to come back to the reverse biased condition. Okay, this is the transition time. So the reverse recovery interval will be completed when the minority carriers which are at the same distance from the junction have diffused to the junction. Again, if you want to get back the same situation, then see this particular time period. After this time period, again if you give the positive supply Vf, again after some time it coming back. Okay, this is what the storage time and transition times of the diode. Immediately they will not change. See, remember one thing, all these time instants what I am discussing here, storage time, transition time, are very very minute things. They are discussed whenever we are going in depth of the operation of the diode. Okay, but when you are going the ideal practical characteristics, this storage time, transition times are not at all considered. They will be in the very small instance, nano and picoseconds of duration, so that's why they will not be considered. But when you are up uh, really discussing the entire in-depth operation, then this storage time and transition times came into existence. Okay,